Hello everyone and welcome to new discussion. Today we are going to discuss raster data compression techniques. This is in two parts. So, first we will take part 1. Please recall the discussion which we had related with vector data compression techniques. Though vector data does not provide that much compression because of less redundancy, but in case of raster data we get lot of redundancy. This is just one example that how basically what we are trying to accommodate as much as data possible within whatever the space is available or in minimum space, not optimum space, but in minimum space. Like example here, in a small car so much of goods are being planned to keep, that means things would be compressed there. And this is the data compression is the same problem as a problem with the small car, and lot of goods are there or stuff is there. Now, what basically the why we want to compress, the two reasons. First is this storage space issue is there, because we want to reduce the storage space, and so that lot of space is available for other storage or other works. And secondly also during the transmission from one end to another end through internet, we would like to reduce the size of the data, and that is why the data compression is required. So, also there are some compression techniques especially associated with raster data compression, which are which compress the data in a manner that even in the compressed form you can use them, and we will see some examples of that also. So, this is a big field now about the data compression, and lot of options are available, and a lot of copyright protected options are also available. So, details about those may not be available with us, but to some extent we can try to understand what is that algorithm or approach, and what kind of compression these tools provide to us. So, the same thing here, that one is trying to keep as much as stuff inside a bag here. Basically the purpose here is to eliminate data redundancy. The data redundancy, if there is a data, if I talk about the raster data, if there are a lot of pixels or cells are having almost same value or same value, then by some means if we can code them in a manner that we do not have to store for each cell or each pixel, rather than a group of cells or pixels can be stored with a one code, then we can achieve good compression. So, that basically data compression eliminates redundancy and try to find a code, and there are various ways of doing this thing with less data volume. Ultimate aim is to reduce the size of the file, so that it can be stored in the system, and as well as it can be transmitted through internet by either email or some other ways. So, that is the basic purpose here. Now, about this point which we will have about that whether all data compression techniques are constructive or lossless, or which or there are some techniques which can create a destructive effect on the quality of the data, because nobody would like to have would like to compromise with the quality of the data, but there are techniques and very popular techniques are also there. The data compression which can be achieved as we have been discussing in a higher way by applying data compression to the raster data. Vector data inherently do not have redundancy, whereas raster data generally inherently having redundancy, especially if I talk about satellite images, or if I talk about digital elevation models, that is the raster in grid form for a flat area or less undulated area, then this issue or this advantage of data compression can be achieved. So, basically what it is done is that in the surroundings, in neighboring similarity is searched, and equal pixels or cells means they are having the same value, and then they are stored in a manner giving a code, and they are stored in a manner that they will require less space. So, obviously we are discussing now the raster data compression techniques, as we know that raster data is stored in terms of rows and columns, and each cell here represents either pixel or cell, depending on I am using a grid or image respectively. And as you also know that units in the raster are always square, and all are uniform in size throughout the data file. And there are various image formats are also there, and also we know that raster is a continuous data, and that is why there are high chances of getting redundancy. Various formats which are known to us, like tagged information file format, or in short we write TIF, or a TIFF file we also called, this GIF file, which is a graphic interchange format, file format, and in short we write GIF. And then some software specific, like ADAS is a digital image processing software. So, they are having their own format, and that is called .img format or Imagine format. Though most of the good softwares, GIS or digital image processing softwares, because this technique, the raster data or data compression technique is common in both the fields, in digital image processing as well as in GIS. So, most of these softwares will allow you to handle such data, either TIFF, GIF, IMG or many other raster data formats, and will also allow you to save as from one format to another. But whenever you do this exercise or a step, whenever or this operation, make sure that the whatever the new format which you are choosing should not be a lossy format or destructive format. It should be always a lossless format, because we should not generally in a real serious scientific applications, we do not want to compromise on the quality of the data. As you know that raster data are spatially autocorrelated. That means many neighboring pixels or cells can have same or similar pixel or cell values, and all things, as we know, are related, but nearby things are more related than distant things. This is a tabular theory. In 1970 he has given that there are chances that whoever is nearest get influence maximum than a far distance, and this is now also seen in the corona pandemic, that we are advised that we should keep at least 6 feet or 2 meter distance between two persons, so that we do not get infection. And so, if we keep the distance, the influence would be little less or really less in case of corona. So, the same thing here, that all things are related, but nearby things or neighboring things are more related than distant things. And because of keeping this principle in mind, we expect that neighboring pixels to have similar values. And especially, as I have said, in case of if we are handling satellite images of a snow covered or a desert terrain, then these are the areas where sometimes featureless. We say featureless, because featureless, why? Because the values of pixels are having almost same value, and therefore we can compress these images or digital elevation models which are having less variations in the elevation values or no variations, and we can compress them very quite significantly. So, repeating pixel values, and then code is given and a pair of numbers. Now, I am in order to explain different techniques, basic techniques, I am not going for some other techniques which some are even copyright. So, we do not know much details. So, 4 techniques I am going to talk, 4 basic techniques which have been implemented in GIS or digital image processing softwares, and a variant of these techniques are also seen here and there in different softwares. So, for simplicity, what I am going to do, I am going to take a very binary image, and just for our understanding, the grid or these rows and columns are shown as a mesh, but really that raster data is stored just in a two-dimensional matrix and no such boundaries are there, but or cell boundaries are there. But for just to develop understanding about raster data compression, I am using this grid to show, or this wire mesh to show how compression can be done using different concepts. Two areas, because say binary image, so one is white areas and one is the dark area, and so we say there in the dark area or black area is having 0 value, white area having value 1, and this is since binary, so only 2 values are possible. So, when we observe this image, what we see that there are two areas, two distinct areas, and therefore, rather than coding the large area, our example and technique, these compression techniques will try to code the smaller area, and just re-emphasize that point that to develop our understanding about the data compression, especially raster data compression, I am taking the simplest possible example. There may be complications later on or in real data compression techniques, but first we have to understand the fundamentals. So, if I talk the first technique, which is the chain quotes technique, in which the same area, the dark area will be coded, and how it is coded, that let us discuss that part. So, that in this one, the boundary of the region, this boundary which is marked here, the black boundary will be coded and can be given in terms of its origin, from where it starts, and then unit of vectors and a sequence, and that too in cardinal direction. The cardinal direction means here in north, south, east, west. So, what these directions can be, here a different approach has been followed, and this is just code. Do not take as a number, it is a code basically. So, for east direction the code is 0, for north direction it is anti-clockwise. So, if I draw here, then for east is 0, this is 1, and for west 2, and for south 3. So, likewise these codes have been assigned here. Now, if somebody is writing their own program, they can give codes say for north 1 or for north 0, does not matter. Accordingly things will be done. Just for we have to code. So, these values have been given, and I have said that these are just not numbers, but these are codes, though they are being represented in form of numbers. So, if we start for coding this black area or dark gray area, then we start at row number 10. Why we start at row number 10? Because that is the cell of this binary image from where we are going to code this one, like this. So, column 1, and this is column 1, this is row 10, and then region is coded clockwise. So, then we will keep moving like this and accordingly. So, let us see how we can code this. So, this exercise has been done for this image, and as you can see that these are the code, not number, or you cannot perform numeric value, otherwise one would say that how you can have 0 power 2. So, this is code, 0 is the code. So, we start with a 0, that means we are moving now towards the east direction, 0 for east, then one cell towards the north. So, 0, then one cell towards the north, then 2 cell towards the east, then 2 cell towards the east, then 1 cell towards the south. So, 1 cell towards the south and then again 2 cells towards the east. And likewise, we come at the end and then we say 1 cell here and then this row number 1 here and then we are going 3 cells. And therefore, the entire polygon which is having the black cells or having 0 values are coded, and automatically the other region is also coded, and by which instead of storing values for each cell, and large area is having uniformity and therefore redundancy in this particular image, which can be coded by only giving these values. So, this way we can do the chain codes. Now, there is another coding which is little variation from this chain code, which is called run length coding, or RLE, it is also called RLE, and this is lossless, non-destructive coding technique. And sometimes people write in literature either coding or encoding, it's almost same thing. So, I have mentioned both things here. Now, in what is in run length coding is a widely used compression techniques, and many softwares like ADAS or ArcGIS or many softwares you would see they will mention in this RLE way, and they will mention in some form RLE rather than run length encoding. So, it does not matter, and then the primary data elements are pairs of values or tuples consisting of a pixel value and a repetition count which specify the number of pixels in the run, because here we are running along the boundary, that is why it is called run length, and counting the length along the boundary. So, data are built by reading successfully rows by row through the raster data, input image, input data, creating a new tuples every time the pixel values changes or the end of the row is reached, by which we can encode using this method. So, let us take this very good again run length coding depending on the redundancy either in the grid or in an image. So, we will see. So, run length codes this RLE for the same image. If we run, and this is how it is going to have, that it allows the points in each mapping unit, and mapping units are over here the cell, this one like this individual cell mapping units, and these are stored per row. So, row by row, and that is why run length. So, running along the length of the row and from left of course to right of a begin cell and then end cell, and likewise coding will be performed. So, if I have to code, so first code first row which is the 9 which is having these black cells. So, for 2 3 that means run between column number 2 to 3, then there is a gap because of white pixels. So, no coding will be done. And then 6 6 6 6 is here, just one cell, and the length is just one cell. Then 8 to 10 is here, and then it will go for the next row and then another row till it reach to the last row of the data. So, for 10 it is just simply 1 to 10, it is all black, and likewise we can code the entire black area of this particular image. Now, run length code for little complicated area, if we are instead of having just binary image, if we are having some a theme which is going to be coded, like here the example is given in the bottom, then in a simple run length code it will be done like this. But here we are having 4 categories instead of 2 categories we are having 4 categories. So, for each category we have to provide one more code here. So, the x, y R, W, these are the the different categories in this map, and that information will also be stored. So, if I take the row 1, then 4x. So, first 4 are there and they will assign this category which is yellow color, then 2W, then 2W like this, then 3R means 3 blue cells, and so on so forth. So, it is not that only the binary, but of course, complicated things can also be stored without much problem using this concept of run length encoding or RLE. So, what we see basically the search is done first to find out the smaller area. So, that larger area should not be coded, smaller area should be coded, and that is what it is then. And if we are having multiple attributes within a map, then also it is possible to do it. So, this recording of cells within each row, there is a code 1 and then there is a code 2 also, that it can be done something like that also. So, it is already when the whatever is written first, it is row 1, then row 2, and this is last row. So, little different variations which you would find in all these compression techniques. When people implement, they apply their own mind and innovations, and sometimes may give better results. Another example of run length coding is given here, that you can have a full coding for this entire, and the table will store all that information also. So, here run length coding values are 129 values are there, which instead of 256 values, if we store in this form raster. So, instead of that, if we code in run length coding, then we will end up only 129, and that means we are getting rid of redundancy, and further that also means that we are achieving compression. But this is a very small size image. Many times we handle really huge size image, and therefore, reducing from 256 to 129, we can achieve a very high compression, almost half. Now, the third type of compression technique is called the block codes. Block codes, as name implies, the blocks are first constructed, which will contain values of cells which are uniform, and the first largest block is coded, and then second largest, and till you reach to the unit level, and unit here is our, of course, the cell. So, let's see that how it works. This the idea of run length codes, as can be said, instead of just this black codes, that instead of going through only the in one direction, that is in along rows, we can go in the now 2-dimension or 2-dimension things by using a square blocks to area to be mapped. And as you can see here, like this blue square, which is in the almost here in this part, blue square is 4 by 4 cells. That means 16 cells in one go can be coded. But in this example, binary image example, that is the only block which can be created of 16 or 4 by 4 cells. Then we have to go for the next size, and next size here is, because it is a block, a square shape, that means next size can be 2 by 2. So, then you are seeing many red boxes are there, and the next one would be of course unit level. So, then there are many boxes which are still remaining out of blue box and out of red blocks. So, let us see how these will be coded. That the data structure consists just 3 numbers. What are those numbers? The position, the size, and the content of the pixel are stored. Here content, here in this case all cells are having value say 0, this is binary, all white cells are having value 1. So, in this one the image can be stored by 7 units, which are unit level means single square. So, there are 17, So, there are 17 such cells which can be stored here like this, and then there are 9 4 squares, 9 these red cells, there are total 9 of having 4 cells in each, and then of course one which is having 16 squares or consist of 16 cells, and that is only one, by which we can achieve quite good compression employing this technique which is called block codes. Now, here how you will achieve better efficiency or better compression if your data, input data is having lot of redundancy, that is almost true with everyone. So, the larger the square which can be created or fitted in any given region, and the simpler boundary, the boundary of this shaded area in this one or dark area, more efficient block coding becomes. So, if we want to achieve better compression, then two conditions are there, that we should be able, or this coding should be able to create large blocks, and the area which are being coded should be simpler. And this can only happen, like I have given the example, in case of say satellite images representing a this ice sheets like Antarctica or other places where a blanket snow cover is there, and almost all pixels are having same value, and therefore you can construct or this coding will construct large blocks having same value and high compression. Also, high compression can be achieved in desert areas or high densely forest covered areas, where again high compression can be achieved, because the variation in the neighboring pixels is going to be hardly anything or little, and that way we can do it. And also the area would not be complicated, which can be coded. However, if we are having multiple attributes instead of single attribute in the previous example, then of course that can also be coded, but of course that kind of compression will not achieve as in case of binary, but does not matter. So, here if I have to store, then we have to store in a form of table as in previous examples also, and then size and the values. So, if I take that row 1 column 1 row 1 column 1, this is R, which is given the green color, and what are the size? There are 4 by 4 size. So, the origin is given through this row and columns, the size is given and the value is given, that is attribute value, and this way you can store the entire image, though it may have multiple attributes. Multiple attributes means individual cells or pixels are having different values, but still you may find redundancy by in block coding by constructing a larger squares. Now, this last one which we will discuss, but there are many other, but based on this binary, the fourth technique which we are going to discuss and quite popular, and the variants are also there, and that is called quad tree. As again name implies that quad trees means there are always 4 blocks, and then you are having search and next step is taken. So, let me explain the quad tree first here, and then we will see other details. So, what is done once this image is given for this kind of compression using quad tree, then this is divided in 4 quadrant, and then each quadrant search is made whether there is heterogeneity present or not. If homogeneity is present, like in case of quadrant 0, then no further divisions will take place. However, if a heterogeneity present, like in case of quadrant 3, then further divisions would be done till you reach to the unit level, and unit level here is our cell. So, let us see that quad tree method is more compact representation, which is based on successive division of 2 power n by 2 power n, and that is array into quadrants. So, this quadrant always it is divided into 4 parts till you reach to the unit level. Like here this has been done, and that entire image, the input binary image, is divided in 4 quadrants 0, 1 and 2, 3. Again these are, though these are numbers, but these are codes. So, there is, one can argue that why not 0, 1, 2, 3, okay, you can do it likewise, does not matter. So, first divisions are made. Now, no further divisions are required for quadrant 0 and quadrant 1. However, the further divisions are required for quadrant 2 and quadrant 3. So, we will concentrate for time being on quadrant 2. So, then further this quadrant 2 is divided into 4 quadrants. So, likewise it is divided into 4 quadrants. Now, again search is made, and still we have not reached to the unit level, and still heterogeneity is present. Then further each this quadrant will be divided in 4 quadrants. So, if we concentrate on this northwest quadrant, then again it is divided in 4 quadrants like this, and the same way again search is made. So, quadrant this one and the southwest quadrant and this southeast quadrant both have achieved the homogeneity, and therefore, there will not be any further divisions, but this northwest quadrant and this northeast quadrant still are having homogeneity, heterogeneity, and therefore, further divisions would be made. And if we made 4 more divisions, then we are achieving the unit level. And then how coding is done. So, coding, as you can realize that initially, like here for this we are having for this block, that is block 2, we are having first that is written say 2, then further divisions are made. So, again the same numbering process will be followed, that 0, 1, 2, 3. So, this becomes our block or quadrant 0, and therefore, for this cell if I go, then it is 0. Then within this, once again divisions are being formed. So, I have achieved for this 0, again divisions are made. So, another 0, because again I am going to handle northwest quadrant, and within northwest quadrant again 4 divisions are made, and finally I come to the unit level, and the last one is the this northeast quadrant, which is 1. So, that is why it is code 2001, and by this we can code the entire image using quadri concept. So, quadri method, as we have discussed, is more compact representation or data compression, more efficient by dividing this 2 power n by 2 power n into different quadrants. And this is tree, quad tree. So, basically it is a inverted tree. So, first we start for the entire image, and then 4 divisions are made, like this should be 2, and then there are further divisions till you reach to the unit level. So, it is example is given here, and each cell here is having some value which is 1, 3, and here lot of heterogeneity is there, but this southeast quadrant you do not have much heterogeneity. So, what is done here? 1, now homogeneity has been received, no further divisions. In case of 3, homogeneity has been received, no further division. So, initially this image was divided into 4 quadrants, search is made whether homogeneity has been achieved or not. If yes, like in case of 1, no further division. In case of 3, yes, and in case of 8 also homogeneity has been achieved, no further division are required. Only further divisions are required in case of quadrant 2, and quadrant 2 here is further divided into 4 quadrants, and each quadrant is having a cell value which is given here. So, likewise, even instead of having just binary image, also you can do on images which are having various pixel values, not only just 2 types, 0 or 1. So, this way we can compress very significantly. Now this quadri having multiple attributes example I have already given. More complicated things can be done, and here also again original image is divided in 4 quadrants 1, 2, 3, 4, and then here no further divisions are required, like in this is 2, so this is 0, this is 1, this is 2, and this is 3. So for 2 no further divisions are required, for 0 no further divisions are required, but for 1 divisions are required, and for 3 divisions are required till you reach to the unit level. So quad, that means every time you keep dividing your image into 4 quadrant, and you do it till you reach to the unit level. And since in other way we can understand is a inverted tree. So these two terms quad and tree are used to form. Now there may be an argument. So far the examples which we have taken are all image shape was square, and this implying or doing coding using quad tree becomes much easier. But in case suppose the input image is not square in shape, that means number of rows and columns are not same, and it is having rectangular kind of thing, then what would happen? So no problem. The first the system, what it will do, the algorithm, first it will go and make the image square by bringing some value here. So here this is the center of image in this particular example. So in order to make like a square this one, extension will be done on this side, so that this also becomes one square here, and then on this side also. So then this block, all blocks becomes square in shape. So one row and one column, top row and right column will be created with the say no data values, but still these will be coded, and therefore you can achieve still quadrant. Example is given here that the root is divided, that means overall image is divided in 4 quadrants 0, 1, 2, 3. Then the quadrant 2 is further divided for 0 and 1 and 3, their homogeneity has been achieved. So 0, 1 and 3 homogeneity has been achieved. So no further division for 0, 1 and 3, whereas for 2 further divisions are there. So this is our quadrant 2, and then again here also keep doing till you reach to the unit level. So here this 3 layers representation, 3 layers divisions will allow us to achieve the coding, and your attribute table can store all related information, especially about the attributes here, and by which we can achieve. But these are very schematic and simple examples. But as I have shown that multiple attributes can be handled quite easily by all these techniques also. Now how a quadri has been represented. So there will be some issues about the boundary. If you are having a scenario something like this, in the left image what you are seeing, this orange area or brown area is having a very smooth boundary. But when we will code it, it will become a stair steps case, a staggered kind of thing, and that is the only problem which will arise, because when we decompress it or uncompress it, at that time we cannot achieve this smoothness, because basically what we are doing, we are converting vector to raster, and as we have discussed earlier, that whenever we do like this, there will be always error. Both transformations from vector to raster and raster to vector are not complete transparent. That means there will be introduction of some errors from one conversion to another. This is what you are seeing, and this error basically is highlighted in the boundary part. This is what you are seeing in this example. Now there is also a technique, and most of the techniques which we are discussing are lossless, constructive techniques. That means that whenever I want, I can come back to my original image quality without losing anything. This is what means is lossless. And lossy techniques or destructive techniques like JPEG is one of the examples which will not allow you to reach to your original image. So, the quality of image is damaged, and that is why they are kept in the category of lossy or destructive technique. So, in this Huffman coding compression technique involves preliminary analysis of frequency of occurrence of cell values. Every technique first will analyze the image. As soon as it is given to the system, it will analyze, and accordingly then if you, whatever the option you choose, it will do the next step. So, here also it is analyzing the frequency of occurrence of cell, how frequently the same value cell is appearing. So, you can say a frequency based kind of technique, and this technique creates for each symbol or for example each category or each value of a pixel or cell a binary data code, and then length of which is inversely related to the frequency of occurrence, and by which you can achieve this compression. So, here input image is given on the left side. There are 3 types of pixels are there. They have been given code blue, red and green. So, if what we see, the frequency of red pixels are is the maximum compared to what you are having blue and green. So, this will further add the understanding about the technique. So, where this Pxi is the number of occurrence of this occurrence of certain intensity value, and the total num is this total num is the total number of pixels which are in the input. So, what is how many pixels are having same value, that will be also given there. And example for say for example for blue cells, the total number of blue cells in this input image are having 0.25 means just a quarter frequency, means 1/4 of the total, and whole image is 1. So, that is why it is 0.25. Now, I am leaving these 2 images, whatever we have discussed, these 2 exercises I am leaving for you to do it at your end. One is this one and another one is also for run length. So, the first one where this you would do it that compress the following raster file with the compression techniques, and the compression techniques here is run length, which you have learned in this discussion, and how much space is needed for storage. So, you have to calculate. If we assume that the bytes, that 8 bits, 1 byte equal to 8 bits can be used to store data values. So, if this is the situation, how this will be stored, that you can do it. This is the exercise, though the results are already given, but nonetheless you should try by yourself that how you would achieve. And then another way that how you would write this thing. So, please go through. I am not discussing in much detail about these 2 last slides. Thank you very much.